For many, the mere mention of turbulence evokes a sense of unease, conjuring images of shaky flights and spilled drinks. Turbulence, that invisible force of nature, is often misunderstood and feared by air travelers. It's important to remember that turbulence is a normal part of flying, a common occurrence rather than an anomaly. Just as a ship navigates through ocean waves, an aircraft encounters varying air currents and pressures during its journey. While turbulence can undeniably make for an uncomfortable ride, it's crucial to understand that it rarely poses a serious threat to flight safety. Modern aircraft are engineered and built to withstand forces far greater than anything they're likely to encounter during routine turbulence. Moreover, pilots undergo rigorous training to anticipate, react to, and manage turbulence effectively. Think of it this way: turbulence is akin to driving on a bumpy road. You might experience some jolts and vibrations, but your car, if well maintained, is designed to handle such conditions. Similarly, a plane encountering turbulence might shake and bounce, but it remains structurally sound, its wings designed to flex and absorb the stresses. The key to a smoother flight experience lies in understanding what turbulence is, what causes it, and how pilots mitigate its effects. This knowledge can empower passengers with a sense of control, replacing fear with informed awareness. In the following sections, we'll delve into the different types of turbulence, their causes, and how airlines prioritize your safety amidst these atmospheric undulations. Turbulence, in its simplest form, is the unstable movement of air. Imagine a fast-flowing river encountering rocks and bends. The water churns and creates unpredictable currents. Similarly, when air masses with different speeds, temperatures, or directions collide, they create turbulent zones. There are several types of turbulence, each with its own characteristics and causes. One common type is thermal turbulence, caused by rising columns of warm air, often encountered near mountains or on hot days. Clear air turbulence is trickier, occurring in clear skies without visible warning signs, typically associated with jet streams, narrow bands of high-altitude winds. Mechanical turbulence arises from the disruption of airflow by obstacles on the ground, such as mountains or tall buildings. Picture the wind swirling around skyscrapers. Aircraft flying through these disturbed air patterns can experience turbulence. Finally, wake turbulence is generated by the wingtips of aircraft, particularly large ones, and can affect trailing aircraft. Understanding the cause of turbulence helps pilots anticipate and often avoid it. Weather forecasts, radar systems, and communication with other aircraft provide crucial information. For instance, knowing that a flight path crosses a mountainous region on a sunny afternoon alerts pilots to potential thermal turbulence. Turbulence can have varying impacts on flights, ranging from mild inconvenience to operational adjustments. For passengers, turbulence often manifests as bumps, drops, or vibrations, potentially causing discomfort, anxiety, and in rare cases, minor injuries if seatbelt signs are disregarded. From a flight operations standpoint, turbulence can impact an aircraft's altitude and speed, requiring pilots to make adjustments to maintain a smooth and controlled flight path. Severe turbulence might necessitate altitude changes to find calmer air, potentially affecting fuel efficiency and flight duration. While turbulence can cause discomfort, it's crucial to remember that modern aircraft are designed to withstand its forces. The wings of an aircraft are engineered to flex and absorb the stress of turbulence, ensuring the structural integrity of the plane. Think of it like a willow tree bending in the wind. Its flexibility is its strength. Pilots undergo extensive training to handle turbulence effectively. They learn to interpret weather patterns, use onboard radar systems, and communicate with air traffic control to navigate turbulent areas safely. Their expertise ensures that even during bumpy rides, the aircraft remains under control and passenger safety is paramount. Behind the scenes of every smooth flight lies a combination of robust aircraft design and rigorous pilot training, both crucial in mitigating turbulence risks. Modern aircraft are built with turbulence in mind, incorporating numerous safety features and structural reinforcements. One key aspect is the aircraft's wings. Unlike the rigid wings of early aircraft, modern wings are designed to flex and bend, absorbing the energy from turbulence and preventing structural damage. This flexibility, combined with lightweight but strong materials like composites, allows the aircraft to ride the waves of turbulence much like a ship handles ocean swells. Furthermore, aircraft undergo rigorous testing in simulated turbulence chambers to ensure they can withstand extreme conditions, far exceeding those encountered during regular flights. These tests subject aircraft to various turbulence intensities, verifying the strength of their wings, fuselage, and tail. Pilots, on the other hand, undergo extensive training in flight simulators that replicate various turbulence scenarios. They learn to anticipate, recognize, and react to different types of turbulence, employing various techniques to minimize passenger discomfort and maintain a steady course. Section 5. Turbulence versus aircraft strength, understanding the limits. One of the most common anxieties associated with turbulence stems from the misconception that it can cause an aircraft to break apart mid-flight. It's essential to understand that aircraft are engineered to withstand forces far exceeding those encountered during routine turbulence. Think of it this way. For an aircraft to suffer structural damage from turbulence, the air would need to be moving with the force of a tornado or hurricane. While severe turbulence can occur, it's extremely rare, and pilots are trained to avoid such extreme weather phenomena. The wings of a modern aircraft, for instance, are designed to bend and flex upwards of 6 feet without breaking. They're built to withstand forces several times greater than the aircraft's own weight, providing a significant safety margin even in severe turbulence. The real danger of turbulence lies not in the structural integrity of the aircraft, but in the potential for unsecured objects or passengers to become projectiles. That's why the fastened seatbelt sign is crucial. It's the single most effective way to prevent injuries during turbulence. Section 6. Clear communication is key. Pilots and air traffic control working together. Air travel is a highly coordinated dance between pilots and air traffic control, working in tandem to ensure the smooth and safe flow of aircraft through the skies. This collaboration becomes even more crucial when turbulence is a factor. Pilots rely on air traffic control for real-time weather updates, including information about turbulence reported by other aircraft in the vicinity. This constant flow of information allows pilots to make informed decisions, such as adjusting altitude or route to avoid areas of known turbulence. Similarly, when pilots encounter unexpected turbulence, they immediately inform air traffic control, providing valuable data about the location, intensity, and altitude of the turbulent area. This information is then relayed to other aircraft in the vicinity, allowing them to take preemptive measures to minimize passenger discomfort or adjust their flight paths accordingly. This continuous loop of communication between pilots and air traffic control acts as an invisible safety net, ensuring that everyone is aware of potential turbulence and can take appropriate action to navigate it safely. It's a testament to the collaborative nature of aviation, where safety remains the paramount concern. Section 7. Fasten your seatbelts. Passenger safety during turbulence. While turbulence rarely poses a serious threat to flight safety, it's essential for passengers to do their part in ensuring a smooth and secure journey. The single most effective way to stay safe during turbulence is to keep your seatbelt fastened whenever seated. Think of your seatbelt as your personal safety net, keeping you secured to your seat in the unlikely event of sudden and unexpected turbulence. Just like you wouldn't drive a car without wearing your seatbelt, the same principle applies to air travel. In addition to keeping your seatbelt fastened, following crew instructions is paramount. Flight attendants are trained to assess and manage turbulence, and their instructions are designed to ensure passenger safety. If they advise you to remain seated, it's crucial to comply. Remember, turbulence is a normal part of flying, and modern aircraft are designed to handle it safely. By following these simple safety measures, you can minimize any discomfort and enjoy a stress-free flight, even when encountering bumpy air. Section 8. Conclusion. Weathering the storm. Turbulence, while often a source of anxiety for air travelers, is a routine part of flying, akin to encountering bumps on a road trip. Modern aircraft are engineered to withstand forces far exceeding those encountered during regular turbulence, and pilots undergo rigorous training to anticipate, manage, and navigate through it safely. Understanding the causes of turbulence, the science behind aircraft design, and the crucial role of pilot training can empower passengers with knowledge, replacing fear with informed awareness. Remember, turbulence is rarely a threat to flight safety. It's more about passenger comfort and operational adjustments. So the next time you encounter turbulence, remember that your aircraft is built to handle it, your pilots are trained to navigate it. And by following simple safety guidelines, like keeping your seatbelt fastened, you can weather the storm comfortably and arrive safely at your destination. Happy travels!